Alright, let's talk about limits by direct substitution. So for these limits, rather than graphing and looking at the left and right approach, let's talk about how we could solve them more algebraically. So it says find the following limits for the function. So one of the first things that we can try is what we call direct substitution, or just plugging in our input x to our function to see what our output is and if it exists. So let's go ahead and try this one. Let's plug in 2 and see what happens. We'd have 2 squared plus 1 over 2 plus 4, which on the top would be 5 and on the bottom would be 6. So this one would be approaching 5, 6. So it's just as easy as plugging it in. If the point exists itself, then that means that our function is going to be approaching from both sides this value. Okay, let's try this one for a polynomial. Limit of 2x squared plus 3x minus 1 as x approaches -1, so we would just plug in -1. And we have 1 squared would be 1, 2 times 1 minus 3 minus 1 would be 2 minus 3 minus 1, or -1 minus 1, which is -2. So this also exists. That means from the left and the right, this polynomial is approaching -2. Last one. If I plug in 0, I have 0 over 0 plus 1, which is 0 over 1. Remember, having 0 on the top is fine. 0 divided by anything is just 0. So this one also exists. What you're going to see that happens sometimes is when you plug in your x value, you might get something that's undefined, such as, or not a real solution, such as when you have the square root of a negative, or when you have 0 on a denominator. And when that happens, then we might need to use a different strategy. But one of the first things that you can try is just direct substitution.